What's up, pre-calculus students? We are going to work through the free response homework. We told you in class that you don't have to do all of these problems. I'm going to focus my attention on one problem at a time, and you should be focusing your attention more on problems 1 and 4, and then probably reviewing a little bit of 3, because we did question number 2 a lot in the most recent unit. Just so you know, free response will always look the same every single time. Question number 1 and 2 are always going to be calculator questions. 3 and 4 will be no calculator. And let's jump into 1. We have some function f, we have some table values, and we have some function g. Probably should just graph g, which I'll do. Make sure you type it in correctly. Don't necessarily need to look at it. Let's look at question 1. It's always going to be finding a function value. So h of 1 is literally just g of f of 1. So it's g of f of 1. They give you both notational forms of composition. We found that f of 1 is 6. So I just need to find g of 6. And we remember from unit 11 in our class that you can type in y1 of 6, and it'll plug 6 into the function. You could also just plug in 6 into g and get that same value. Okay, don't think you'll need to show any more work besides just this, the composition kind of breaking down. Find all the values in which f of x equals 4. So what are the x values in which the y is 4? I mean, it's pretty obvious. You can see x equals 2 and 5. Find all values in which g of x equals 5. Now we're actually using our calculator. When you did your no calculator homework, you did not have to worry about using your calculator much, the no calculator multiple choice questions, but now you do. Just be careful. You might have multiple solutions. Maybe you start in a Zoom standard. Zoom standard is your typical 10 by 10 window. You should see what the function looks like. You can see the end behavior. Be ready to adjust your window, maybe making your x's bigger. You can see the cubic. You know what the end behavior is going to be, so you don't have to look to the right or to the left. You're seeing pretty much all of the cubic. You just have to now go in and find all of the intersections. Make sure you get through guess to finding the intersection. Your decimal places need to be to the third decimal place. You can round or truncate. I just like to truncate, that way I don't have to think. You guys are not comfortable truncating, but truncating is allowed. So I'm just going to leave 1.412. If you put 1.413, that's fine. Determine the end behavior of g as x increases without bound. X increases without bound. Express your answer using mathematical notation of a limit. Like, you won't get points unless you do. The limit as our x increases without bound, that's as x approaches infinity, of g of x is infinity. Why? We're going up and to the right with our function. The end behavior of this cubic is down to the left and up to the right. So as my x's approaches positive infinity, my y's are approaching positive infinity. Determine if an inverse can be constructed for all values of the domain. So this is good. It kind of brings us back to thinking about inverse trig functions and why you can only have one output for a given input. And here's something that I Notice the inverse, which will have all the flip-flop points. We'll have 6, 1, 4, 2, 0, 3, negative 1, 4, but then 4, 5. This is a problem. You're not allowed to have an input that has two outputs. That's not a function. Function takes one input and gives you one output. So the answer is no. Probably the correct explanation they're looking for is F's output. You say f of 2 equals 4, f of 5 equals 4. And you cannot have, I'm trying to just keep it simple. If, like, I don't want you to try to memorize. So there's multiple of the same outputs. F is not what we call one-to-one, which means we don't have like distinct X's and distinct Y's, which then flipped works. Not exactly sure what they're going to be looking for in terms of their justification, so I'm going to just leave it at that, and we'll talk about it in class if we need to be more. Oh, well, that was CI, and this is CII. So the answer is no, and CII is give a reason for your answer. Let's look at the course description for invertibility really quickly, and we will talk about what their definition for being invertible is. So it's kind of what we were talking about. It's each output is mapped from a unique input value. So we could say the output 4 is not mapped from a unique input value. There's two input values that map to the same output values. Flipping of the points is kind of what we know. I think we kind of covered it. So the output value 4 is not mapped by a unique input value. That is exactly what they want to hear, is that the output values are mapped by unique input values. And if we see that again in the other question ones, we'll be ready to go. Okay, same deal. Given a table, we're given another function. Probably should go ahead and graph G, have it in there. Maybe use alpha F1 so that you don't make mistakes with how you type it in. You type it in just as you see it. Not going to graph it yet, but it's in there. Find the value of h of 4. Another easy question. Just make sure you're ready to compose. G of f of 4. F of 4 is 5. G of 5 we can find using our calculator or by typing it in. 11/5. Make sure your fractions are completely simplified. We do not like unsimplified fractions. You can also go into the graph and press trace, the trace button here. Press 5, enter. You see that 11/5. When is f of x equal to 10? This is f of x. When does it equal 10? When x is 5. That's easy. When does g of x equal 4? We know the end behavior of this rational function should look like y equals x. I see kind of it on the right side. I don't see it on the other side. I want to see. What's up? There it is.
What happened this morning?
What happened this morning?
So I'm pet sitting for this lady. Tonight was the last night I had to stay there.
This is going on YouTube, by the way.
Oh, you're filming?
Yeah.
Okay, bye.
Do you want me to pause?
That's okay.
Did your I can't wait. It's what I thought it would be. So yeah, there's the other half of it. So it's good that we were able to see it. We should know that it's a rational function. It's got a vertical asymptote of -5. We should see the end behavior. So like, yeah, adjust your window sometimes. The solutions, and there's only going to be two, are these. And how do I know there's only two? I mean, you could keep zooming out, but you won't see anything else. So this is going to be it. Include the 0. It's accurate to the third decimal place. Okay, as the end behavior decreases without bound, as x decreases without bound, as x goes to -infinity, what do you see your function doing? Going to -infinity. Now, you could actually do this limit. You could realize that this doesn't matter, that doesn't matter. Your end behavior is going to be the same as x squared over x. You could actually divide to find the specific slant asymptote will be x minus a number or something like that, or x plus a number. But you can see your end behavior is going to be the same as y equals x. Y equals x's end behavior is up and to the right and down to the left. You don't have to show all this work. You could just look at the graph as long as you see all the graph. This is a great example of if you kept your guys in Zoom standard and you're not thinking about the fact that you have a rational function, you might be saying positive infinity. So make sure you're investigating, make sure you do a little bit of math to get your answer to double check. Okay, see, use the table of value to determine if the function f is best modeled by a linear quadratic exponential. They always like to talk about the average rates of change. And there it is. The second differences are constant. This would be best modeled by a quadratic. You don't want to stat edit this. They don't want a reason until CII give a reason. The second differences are constant. They'll accept this. I don't like saying second differences. Probably you could say the rates of change between equally spaced points are linear. You can say the rates of change are changing at a constant rate. The rates of change are changing at a constant rate. Okay, now we're given a graph. Here's another G. Okay. Getting easy points here. These are all worth 1.2, 1, 2, 3, 4, 5, 6. Every single free response question is worth 6 points. And it's usually like very easy points and then maybe one or two kind of tougher points. H of 6 is G of F of 6. This is F. F of 6 is 1. I need to find G of 1. There's G. Plug in 1. Oh, it's undefined. That's good. There's a vertical asymptote. Here, watch. You'll see alpha y4, y1 of 1 is going to be divided by 0. So it's not defined. When does f equal 2? When is the y value, negative 2? Negative 2. When is the y value negative 2? That's at 2. 7.2. Okay, so the end behavior of this is going to be like y equals x squared. So I should be seeing up and up towards the ends. I see there is going to be a vertical asymptote at 1, but I don't kind of see that up and up. You could zoom fit. Sometimes zoom fit will automatically look at all the y's in the interval of x's that you graph, and this is nice. This is a lot better seeing this. It doesn't go all the way towards negative infinity, obviously, but it does a good job showing you that end behavior of y equals x squared, showing you the vertical asymptote. So zoom fit, team, try it out, see if you like it. It'll adjust your y's accordingly. Try to figure out when this equals 7.2. There's going to be 3 solutions to this. I need to shrink my y's a little bit. Again, I'm not going to see that end behavior again. And I'm not going to see all the things. So we gotta go out some more. There can't be only one. It's got to be, unless, we got to investigate. Yeah, look at that. There is only one. The end behavior is just like x squared. However, it doesn't dip below to the left. The minimum value here is 12. So, yeah, just like be ready to adjust, adapt, see everything. I want to find the intersection, not move things over. You could put 3.060 if you wanted to. All right. As the end behavior increases without bound, we see that g goes towards infinity. We have the same end behavior as x squared. If you want to do that analysis, good. You don't have to, though. You don't have to show that you're looking at x cubed over x, which has the same end behavior as x squared. Is f invertible? This is another no. We have, what was it like? The output values are not produced by a unique input value. The output value is not mapped by a unique input value. That's what they're looking for invertibility. You have multiple zeros, you got multiple, so the answer is no. And you could be more specific. The output values y's between -2 and 2 are not mapped by unique input values. Or you could just do one example. Like you could use 9 -2 and 2 -2. And you could say the output value -2 is not mapped by a unique input value. But I'm going to be a little bit more specific. The output values from -2 to 2, including those, not including 2. 2's fine, but all the values between are not mapped by unique input values. Or you could just use one example. F of 2 is -2. F of 9 is -2. Of the output value, -2 not being mapped by a unique input value. You would have to have f inverse of -2 equals 2 and f inverse of -2 equals 9. Not a function. Okay. Keep it rolling. You guys gotta roll the class. Crawford, can you finish this later? Are you almost done? All right. Yeah. All right. H of 3. Just put it on my desk over there. G of f of 3. F of 3 is 5. G of 5 is -281.02. Probably good to start with Zoom Standard, then Zoom 6, and then maybe switch to Zoom Fit. It's an x to the 4th. We kind of see what we're looking for. Zoom Fitting did not do a great job. I probably would adjust this a little bit more. I don't want to go to -25,000. I do want to kind of see the end behavior of the x to the 4th. I like that. That looks good. So adjusting. So f does not have any zeros. It does not cross the x-axis. It looks like there's a horizontal asymptote. G of x equals 10. Might want to zoom in around 10. Nah, that's good. That's clear. These questions are good, though. They are forcing you to adjust so you can see what this function is, except for the first one. As x increases without bound, my function g is decreasing without bound. Can we construct an inverse of f? Yes. What is the reasoning? Each output value is mapped by a unique input. I guess we're going to have to remember this. It's just easier than try to explain. It's like, oh, yeah, it's like I can flip-flop points. It'll still be a function. How many more do we got? All right, one more. I'm looking for something that has a horizontal asymptote. This does. As x approaches to negative infinity, the y's are going to approach that 5.4 because this is going to trend to 0. Let's think about why I know this. Y equals 2 to the x. We'll have a y equals 0 horizontal asymptote to the left. Shift it up 5.4. Flip it with that negative 0.79. Do a little bit of a horizontal dilation. It's not going to change things. But now y equals 5.4 will be the location of the horizontal asymptote to the left. If we're looking to the right, it'd be going towards negative infinity. All right, so good. Hopefully there's a decrease. Okay, we're good. Yeah. All right, h of negative 1 is equal to g of f of negative 1. F of negative 1 is negative 2. G of negative 2, I can find here or on the home screen, 5.269. F inverse of 1. Okay, so maybe you're not sure about this. F's got the point AB. F inverse has the point BA. I'm looking for when F inverse has an input value of 1. That's when F's output value is 1. So I'm looking for the X value on F that produces a Y value because F inverse is going to map that back. So F inverse of 1 is going to be 2. And maybe just to confirm, F of 2 equals 1. F inverse of 1 will equal 2. Find the zeros of G. Okay, Y equals 0. Graphed, we do have a 0. You don't see it, but it's there. Second calc. Intersect 2.133. You know, this is not that bad, guys. Question number 1. Let's get 6 out of 6 here. As the input values decrease without bound, the output values will trend towards 5.4. That being your horizontal asymptote, just like we talked about. Is F invertible? Yes. What is your reasoning behind the yes? The output values are mapped by a unique input value. I mean, so like this is what you're going to see every time. All right, that's question number 1. 6 out of 6. Let's do it. Peace.